Occasionally in life, we encounter an event that seems to have a binary outcome, though in reality that is not always the case. In this section, we will consider testing, such as testing for viruses, pregnancy tests, or biopsies. Though we might assume that the results of such testing is binary, such tests are not 100% accurate, so there are often false positives and false negatives. A true positive would occur if I went to take a COVID test, I truly had COVID, and the test came back as positive. However, a false positive is when I go to take a COVID test and I do not have COVID, but the test results in a positive. So this false positive is when a test reports a positive, though the test was actually negative. A true negative is when I go to take a test and the test result reports a negative and the test is truly negative. Because tests are not 100% accurate, then a false negative is when that test result returns as negative, though it was actually positive. Recall that accuracy describes how closely a measurement approximates a true value. An accurate measurement is very close to the true value. If a test is p% accurate, then p% of the time the approximated value is correct, while 100 minus p% of the time the approximated value is incorrect. Suppose that a drug test is 95% accurate. If we have a sample size of 1,000 people that are participating in a test, research may tell us that 2% of a population actually partakes in drug use. Out of the 1,000 people, this would represent 20 of those participants that we would expect partake in drug use. The remaining 980 would not be expected to be participating in drug use. Of those who use drugs, of the 20, 95% of those 20 people would be 19. We would expect that the test would have 19 positive tests out of those 20 people. A 95% accurate test, though, may have one negative test from the 20 people partaking in drug use. Of the 980 people who do not use drugs, the test that has 95% accuracy will most likely conclude that there are 931 negative tests from those 980 people who do not use drugs. However, 5% of 980 would be 49. We might expect about 49 positive tests from the 980 people who do not partake in drug use. This would mean that in total, we would have 68 positive tests for drug use out of the 1,000 people. However, of the 68, 49 of those people do not actually partake in drug use. Notice that 49 divided by 68 is 72%. This does seem like a high proportion of false accusations, despite the test being 95% accurate. Let's break this down further. To give us a visualization of this, we start with 1,000 people. Because research tells us that about 2% of a population actually partakes in drug use, 2% of 1,000 is 20, and the remaining 980 people are most likely non-users. After the 1,000 people are tested, we had 4 cases. We had positive tests here, so I have 2 groups of positive groups from the non-users, as well as a positive group from the drug users. Together, that gave us 68 positive tests. However, because there's a small percentage of the population or of the sample that is actually expected to be using drugs, then this group, 19, will be a very different size than the 49, which was only 5% from 980. Therefore, that 49 of the 68 tests, though they returned as positives, we suspect that there will be a high number of false positives, and those persons would take the test again. This is to give you an idea of how the breakdown would work for a test that has 95% accuracy. Once more, the number of false positives here seem large, though the main reason for that is because the group for non-users is so much larger than the group for drug users. 95% of 980 is 931, and we would expect the test to have approximately 95% of those, so 931 true negatives. However, 5% of a large number did lead to approximately 49 false positives. What percentage of negative test results were actually false? Notice that we had 931 true negatives and 1 false negative. We would take the 1 false negative divided by 932 negatives. This percentage, you can see, is quite small. This test is very effective at actually determining if a participant is partaking in drug use. Though it may seem that we have many false positives, you'll see that the percentage for false negatives is very low. In your homework, you will continue practicing these concepts.